This is the second part of 1.4. All right, so for this, we had explicit and we had recursive, and those were called a sequence. A sequence was a pattern that added every single time the same number. Yes? Okay, now what happens with a arrhythmic sequence, which is what we're going to, or I'm sorry, arrhythmic series, is what we do. I'm going to use this example. This is series, arrhythmic series. So this is a sequence, okay? A series takes the sequence and adds them all together to give you a total. So for this one, the series to the fifth term would equal 30. Oh, wait, nope, it's a different example. This would be, what, 5, 12, you with me? 25. Try again.
Would it be 16? The next number?
Oh, no, we're not. We're adding them all together. 1 plus 4 is 5.
Oh,
5
okay.
plus 7 is
35.
5 plus 7.
Oh, that's
12 plus 10. And then 35. Holy cow, that was a little harder than I was hoping. Can I have a calculator? Does this make sense? So what does a series do? Just adds them up. Now, what if I said series 4? What would that mean? For this particular example, it would mean I would add 1, 4, 7, and only up to 10. Notice I went, because really, what does this sequence do? You guys were doing it. You guys were telling me this sequence does what? It continues on, right? It keeps on going. So a series has to have like some kind of stopping point so you can add them together. For right now, later on, you'll get into different class that kind of talks about this. About what happens, how do you have an idea if it converges to something? That's later on. But for right now, that's going to keep on going, and that's never ever going to stop getting bigger. Do you get what I mean by that? So we have to say series 4, that says I want the first 4 terms added together. And so that would be 5, 12, 22. Does that make sense? Now, why is this really easy? It's just addition, and there's only 5 numbers. What if I gave you a sequence, maybe like this one, and I said, I want you to add the first 100 numbers together. Even if you use the calculator, is that going to be very fun? To sit there and punch 100 numbers in and you accidentally hit the wrong button and hit equals, and now you got to start all over again. There will be a formula that's going to help us out. We're going to discover this formula together. Aren't you excited? So here's what, who said no? Watch your mouth. So here's what's going to happen. I'm going to show you again with easy numbers. We're going to try to come up with this formula together, and then we'll use it throughout, and we'll talk about different kinds of questions that can pop up from this formula, because it's pretty straightforward, but there are different things that they can do to make it a little tricky, not necessarily hard. Once you understand what you're supposed to do, it's not hard, but kind of seeing on your first time can be a little scary. So we're going to go with an easy one again. By the way, just to show us if we added that all together, so if we did the series of 1, 2, 3, 4, 5, it should be 30. All right, this and this make a 10, this and this make a 10, so that's 20, and there's another 10, 30. Does that make sense? Yes. What a man saw was a man, I told you, saw this pattern. he saw that, hey, you know what? If I take 2, 4, 6, 8, and 10, and I write the series down in order first, from smallest to greatest. And then I write the same series down, but this time in reverse ordered. And I add them together. What do you notice happened? You got this magic number 12 that popped up every single time. And how many times did that 12 pop up? So repeated addition is really multiplication. Does that make sense? 12 times 5 is 60. Now what's the problem though? Why is that not how much the sequence adds up to? No. Why is it doubled? How many series did I combine together? I did 2 of them, right? So what could I do to fix that problem? Instead of having it doubled, divide by 2, and I got 30. That's what we're going to try to come up with. See if we can see a pattern here. I'll do one more and then see if we can see a pattern. Thank you. Okay, what would I write right underneath this? 16. So 23 is my magic number, right? So 23 times 4. 23 times 4, we can do the math. 12, carry the 1, 72. Yes. 72 divided by 2 is? I mean 892. Sorry. 92. 46. I know, I slacking. What is this right here? What is 7 and 13? There's a reason I did that. 20. 20 plus 10 is? And what's 30 plus 16? Isn't that what we got? So let's think about how we did this. Because really, did we need to do this 4 times to get this special number? What could we really do? What was this? First term and the last term. If we added the first and the last term, every time we'd get that special number. You're right, you with me? How many times did we get this 23? Which is how many terms there were. Are you following me? And then we cut it in. So what if we did the first term, here's our formula, plus the last term, and we times that by how many terms there are in that sequence. And then cut it in half. That is the sequence formula for a arrhythmic. Now the reason I keep saying arrhythmic is because later on in the year we're going to get a geometric and this formula will not work for it. Yeah, there's a whole bunch of ways. It's kind of like tomato, like arithmetic, some people say, like arithmetic. I don't care. It's a rhythmic sequence. Just, it means you're adding to get to the next one. Like even books write it different. Yes. Well, I gotta have, what's the only thing that I need? I need the first term, I need the last term, and I need to know how many terms were in that. So we're going to do that. We're going to do some of these. So let's say, so this is where we get to some of the ones that are a little tricky. So the problem with this is that formula is not very hard, right? First, last, how many terms there are? Pretty simple. So what if they don't give me the last term, but they give me the first term and they give me the common difference and they tell me the term number to go up to? Then I go back to what I taught you, which is the explicit formula. You can find out what that last term is. That's why I had to teach you the explicit formula first before I taught you this lesson. Does that make sense? Okay, here's another. This is a different one, and we're going to do this one together. They love doing this. And this is the ones I love to put on the test because you can't cheat it. What do you think kids love to do if I just give them a series and a sequence and I ask them to add it? They just, especially if there's only, I'm not going to give you one that has like 100 in it. I'm not going to list that all out. That's too long, right? So this right here, you physically can't add them all together because you don't know all the numbers. No, you don't, because you don't need all the numbers. What are the only things you need? In order to have the sequence, what are the only things you need? First, last, and the term number, the number of terms, and then divide by 2. So let's look at this one. Oh, we're going to get there. We don't know n, do we? We know our first term is 2. We know our last term is 79. And then we got to divide it by 2, but I don't know what n is. Not yet, at least. So, and remember in middle school when you did formulas, they kind of like gave you everything, like spoon fed you? In Algebra 2, we don't give you everything, but we give you all the tools to be able to find what you need. So I'm actually going to have to use, I can't just use my series formula to do this problem. I'm going to have to go back and go, wait, I do need my term number. What formula could I use where I have some known information that I could work backwards and find? I need to know what term number the 79 is. Is it the 10th or is it the 100th? I can use the explicit formula. Yes, you with me? A(n), which is the actual term. A1 plus the common difference, n minus 1. I can use this, and as long as I fill in this information, I fill in this, and I fill in this, what's the only thing that's left as the variable? And then I can use algebra to solve for the n. That's called isolation when we do that, by the way. So let's do this. Okay, common difference is 7. I know I'm still going to have n. What's my first term? Now, here's the one that's a little tricky. What is the term? What is in the term that I'm trying to find? What is the last term? So do you remember how the first term was 2 and you put a 2 in there? I'm trying to find what term number 79 is. So that's the one that goes in for an. I'm not trying to find an. I'm trying to find what term number it is. Remember how I told you that can get tricky because there's kind of 2 ways of describing it? I was kind of setting you up for today. Now, a couple ways we can do this, actually, this one problem. We can distribute if we wanted to and solve this. And then we do 79 equals 2 plus 7n minus 7. You see the 2 and the 7 are both on the same side, so I don't work backwards. I think of this as a positive and this as a negative 7. And so when I combine that, that gets me to a. And then I add 5 to both sides. And I get 84 equals 7n, divide by 7. And yes, 12 is what n equals. And then I put 12 in here. And now I'm not going to do the rest of that problem because I'm assuming you know how to add 79 plus 2, times it by 12, and then divide by 2. You have a calculator. Yes. I'm not going to go over. I don't care about doing this on a calculator. if you can't do that, we got bigger issues of why you're in algebra 2. I'm not trying to be mean, I'm being honest. You got this in a calculator, times it by 12, then divide by 2. Order of operations. And I think it's like 486.
So you do the explicit formula and then you plug in the answers to the...
I had to do the explicit formula because they didn't give me all the information I needed. They didn't give me my term number.
So that's the only time you use the calculator.
Or if they might give me the first term. They might tell me that they want the 100th, but they don't give me the last term. So I got to use the explicit to find the last term. So sometimes we have to use the explicit to fill in whatever information over here is missing.
What does the sequence formula find?
All right, good question. What does it do? Well, it adds up all the terms, right? It adds them all up together. So here's what this will make it, I think, easier for you. Imagine we have an auditorium, and each time I go up a row, I add 2 chairs to each row. So how many chairs are in this row? How many are in this row? How many are in this row? So this is a sequence, yes? If I asked you A10, what is that question asking you? That is asking you how many chairs are in only the 10th row. And you would use the explicit formula to find that. Huh? Okay, so I'll do 100th row. Because you got to use the formula. So on the test, it'll be bigger numbers, so you can't just cheat it. Make sense? Now, but what does the explicit formula find? It only finds how many chairs are in that one row. What does S100 tell you?
How many chairs?
How many chairs are in the entire auditorium? That's what the series does, right? It adds 1 chair, adds 3 chairs, adds 5 chairs, adds all those up together to the 100th row, and then you can say how many people can fit in the entire auditorium. Did that answer your question?
Yes, thank you.
Yes. So that's what a series does. It tells you how many things are in that total pattern all together. The explicit only tells you how many are in that one slot. Series tells you in all the slots together up to that row. Questions on that? Before I move on, because I'm going to change it up. It's still the same kind of thing, but the format of it's going to look a little different. All I got to teach you is format. What questions do you have now for this? Do we have any, or are we good? Oh, you got to find. So this one example right here, if I asked you to find the 100th, you would go, okay, I know my n is 100 because there's going to be 100 numbers in this sequence because I start at 1 and I go to the 100th. We'll see what I mean in a minute. My first row, there was 1 plus how many chairs are on the last row? I don't know that. What do I have to use to find how many chairs are in the 100th? This right here. Does that make sense? Yep, the explicit, which would say 1 plus 2 times n minus 1 or 99. And then whatever the answer that is, that would go right here. Yep. Does that make sense? All right, now this is a funky way of writing this. This is called sigma. Sigma is just a like a Greek letter that we use in math sometimes, and all it means is summation. or add everything together. What did I refer to that as when I said add everything together? Series. So when you see sigma, it's really just saying the same thing. Find the series. Add everything up together. Hang with me because it looks funky in the beginning, but it's not too difficult. It can be any letter. It could be X, it could be J, it doesn't matter. Here's what this means.
You really scared me with that one, like,
When would you use this? There's sometimes that they write it like this when they write the equation.
what the fancy eye? It scared me because I thought it was like.
Oh, no, it's just, no, it's not. I really don't like that they used I, honestly, because I should be imaginary and should be reserved for imaginary, which we're going to get to. I think they use it because we haven't got to it yet. But really, it doesn't matter. It could be any variable. I is not important. What is important is this is the starting number that we're going to plug in for I. And this is the final number. Hello? Hey, what's up? No, it's his teacher. How are you doing? Your sister? I'm trying to keep this boy in line. You want to talk to your brother? All right, that's fine. You're welcome. Hurry. Hey, whatever I do in here, you can just watch it on YouTube. Does this make sense? So this is the first number that I'm going to plug in. And I'm going to plug every number in up to 9. And what that would do is that would get me the sequence. Meaning, plug in 1. What's 1 times 2? 2 minus 6. Careful. It matters. Now, what would be the next number I plug in? I'm plugging in numbers from 1 all the way to 9. So what would be the next number I'd plug in? 2 times 2 is? Minus 6 is? What would be the next number I'd plug in? 3. 3 times 2 is? 6 minus 6 is? Now, if I wanted to have the series, I would plug in all the numbers from 1 to 9, and that would get me the series. And then I could do the summation, which would mean add them up. When I plugged in 1, 1 times 2 is 2. 2 minus 6 is negative 4.
Where'd you get the 3 and all that? You're just going 1 to 9, is that what you're saying?
This tells me what number to start with.
Yeah.
This tells me you keep plugging in, keep going up by 1 until you get to this number here. So you will plug in 1, 2, 3, 4, 5, 6, 7, 8, 9.
So like 2i, so until you get to 2i, you stop.
No. Do you see I?
Yeah.
You're going to replace it with a number, Nick.
Okay.
You're going to replace it with a 1 first.
Yeah.
You're going to get an answer. It's negative 4. You're then going to plug a 2 in for I. You're going to plug that in, do the math, and you get a negative 2 out. You're then going to plug a 3 in. You're then going to plug a 4 in, a 5, a 6, a 7, an 8, and a 9.
Yeah, that's what I'm saying. You just keep, you go 1 through 9.
Yes. Plugging it in for just I, though.
Okay. Yeah, that's what I'm saying.
Yes.
Like 1 through 9.
If it said find the sequence, right? The sequence would be all the numbers listed in this pattern. And if you kept going, do you see how it's plusing by 2? The series is when I actually add them all together. Have I added them together yet? No, I'm just listing all the numbers. And so when there's a list of all the numbers, that's the sequence. Hey, when I do this, I want at the end, the E tells me you can make a list of all of them if you wanted to. And that would be the sequence. And then you could add them all together. Which this one wouldn't be too hard because we're only going to have how many numbers? 9. But it does relate to what we just talked about because I can do, when I realize, okay, this is the same thing, it's just a different way of writing it. What is the only thing I need in order to do to add them all together? What's the formula need? So what can I do to find the first term? I would plug in 1. There's the first term. What would I need in order to get my last term? What's the only thing I need to plug in? I would plug in the 9. No. You're talking about the common difference? 2 would be the common difference.
Would your last number be 12?
Yes. Because you plug in 9. 9 times 2 is 18. 18 minus 6 is 12. And then, because I'm going from 1 to 9, remember the N stands for how many terms there are. If I go from 1 to 9, there are 9 terms. So 9, negative 4, plus 12, divided by 2. And that would tell me the summation of all these added together. Will make more sense. We'll do it again. What does this E tell me that they want me to do? They want me to add them all together. Now, one way I could do this is I could literally plug in 1 for I and get an answer. I could plug in 2 for I, get an answer. I could plug 3 in for I and get another answer. And I could keep going up until I did it all the way to what? 13. Would I want to keep plugging in numbers and getting out outputs? Would that be very fun? What is the faster way to do it? Using the formula, what's the only thing I need? What's the first term? I plug in 1. 1 times 2, or 1 times 3 is? 3 plus 2 is? So there's my first term. Is everybody understanding where I'm getting this? Plus, I could just take this last term, plug it in here. 13 times 3 is 39, plus 2 is? And then, since I start at 1, you'll see why I'm keep looking at this. It's going to change in a second. Since I'm starting at 1 and going to 13, there are 13 terms, so I'm going to put 13 there and divide by 2. Yes? And again, I'm not finishing because I'm hoping you can do this in a calculator. I'm just setting it up because the setup is what I care about. Add the 5 and the 41, times by 13, divide by 2. Got an answer. Use your calculator. Right? Now watch, please. This is where I've been trying to set you up for. Right. What is my first term going to be? Good. I plug in I, 0. 0 times 2 is 0, plus 7 is 7. So the first term is 7. Plus, plug 7 in, 14. 14 plus 7. Remember, don't forget to do that. 21. Now, careful. How many terms are there? Why? We normally start at 1, and if I count from 1 to 7, you go 1, 2, 3, 4, 5, 6, 7, right? There's 7. But when I use 0, 0, 1, 2, 3, 4, 5, 6, 7. So there's actually 8 terms in this one. You've got to be careful because they will do that to you. Right, because we don't normally count with 0. Right, we count with 1. So when we start counting and we start at 0, it adds an extra number that we're not used to, if that makes sense. In how many terms? We're going to do it disappeared. Again, what I personally do is I like first and last term. Those are really easy to me. I'm like, you know what? I don't want to think too much. All I got to do is plug in 3. 3 times 5 is 15. And yes, to me, this is not hard, right? I know my multiplication tables. I know how to subtract and add. That's why it's so important to know those things. To me, this is like clockwork. 15 minus 2 is plus. Plug the 7 in. 7 times 5 is 35. Minus 2 would be. Now, what is my n? Well, since I'm starting at 3, I go 3, 4, 5, 6, 7. So it'd be 5 would be my n, all divided by 2. There won't be too many that are like this. You have homework tonight. For the most part, it will start at 1. But I show it to you because I've seen it in different places where this isn't always 1. So I just would rather bring it to your attention. For the most part, I believe in this book, they started at 1. Okay? You have homework tonight.
Is it due tonight or by Sunday?
No, it's not due till Monday.
Okay, thank you.
But remember to do your work each night, 30 minutes, even on the weekends.
Homework?
Okay, thank
Yep,
you.
you got homework.
1, 2.
Yes. No.
Have a nice weekend.
1, 4, part 2.